a bullet is not fired from a gun, can it still be accurate? If you imagine using a hammer as the propellant, no one would know what posture the bullet would take or where it would fly after being struck. If you place the bullet inside a barrel and then hit it with a hammer, it will travel straight along the barrel. If the barrel has rifling, the bullet will spiral forward along the grooves, improving its flight stability. When you replace the hammer with gunpowder, the high-pressure gas generated by the explosion can shoot the bullet rapidly out of the barrel. But this created a problem. Loading loose powder was very troublesome, making the firing speed extremely slow. Later, engineers designed fixed cartridges, which combined the bullet and propellant into one unit. Striking the primer at the bottom of the cartridge could ignite it, greatly improving the loading and firing speed of firearms. The method of igniting the primer also needed improvement. Using an extra hammer was obviously unrealistic, so engineers designed a matching firing mechanism. First, they added a hammer behind the firing pin, but a hammer alone wasn't enough. It didn't have sufficient energy to strike the firing pin effectively, so they added a linkage beneath the hammer and pressed it with a spring, located in the stock. Pulling the hammer back compressed the spring. Storing energy and releasing the hammer created a strike. Next, they integrated the firing pin and the barrel into a slide. Pulling the slide back pushed the hammer backward, storing spring energy. The slide was connected to the underside of the barrel with a spring, allowing it to return automatically after moving backward. But there was another problem. Without anything to stop it, the hammer would move forward with the slide. Therefore, a sear was needed to lock the hammer and hold the spring's stored energy in place. Under the hammer was a specially shaped cam, and the sear engaged with its tooth at a specific point, preventing rotation and keeping the spring compressed. The sear was then connected to the trigger. Pulling the trigger moved the sear, releasing the locked cam. The remaining spring energy drove the hammer to strike the firing pin. Another issue remained. Without external force, the sear wouldn't reset on its own. To solve this, a sear spring was added, ensuring it automatically caught the cam tooth as the hammer moved. After completing the firing mechanism, the next step was to solve loading. The magazine contained a spring at the bottom that pushed the rounds upward, and the top of the magazine had feed lips to prevent the bullets from being pushed out. The slide had a breech block that could push the round forward against the feed lips. However, the barrel was positioned slightly higher, so the bullet couldn't enter it smoothly. But don't worry, engineers had already considered this. The barrel was connected to the frame with a moving pin. As the slide moved backward, a lug on the slide engaged the barrel's groove, pulling the barrel back and tilting it slightly. This allowed the bullet to be fed smoothly into the chamber. Then the barrel returned to position as the slide moved forward. After firing, recoil pushed the slide and the spent cartridge backward. The cartridge struck the ejector and was ejected out of the slide opening. The slide then returned forward under spring tension, chambering the next round. If you keep holding the trigger, there would be nothing to stop the hammer, and it would automatically strike the firing pin every time the slide returned, continuing until the magazine was empty. This would effectively turn the pistol into a fully automatic weapon. To prevent this, engineers added a disconnector inside the sear. It disconnects the trigger and sear. It is held up by a small spring and only drops into the connecting position when the slide reaches a specific point. Only then, when the trigger is pulled again, can another shot be fired. This ensures the pistol fires one shot per trigger pull.